Oh, because we take notes on
I think I have some under your desk. I think there's some that were in your book when we were hole punching them.
Oh, really?
Yeah, I think those are yours. I put them under there so I wouldn't forget to give them to you yesterday. Are those from your notebook? Yeah, when we were hole punching. I found them on my desk last night and I was like, oh. Okay, a point is moving on a curve, y square root of x, so that the x coordinate is changing at a rate of 3 centimeters per minute. Okay, so the first thing we do is you can draw a picture for this if you want. You can draw a picture if you want. Here's the curve. Here's the curve, and it's moving. Right, this point is moving on that curve. So what is changing? What is variable and what is constant?
What is it?
This is number 6. What is changing and what is constant?
We have the x is constant. Is changing at 3 centimeters.
Okay, so our variables and our constants. Okay, so our variables are going to be x and y. Those are both changing, right? As time goes, x and y are changing. The dx dt is constant. Yep. And then it says when the y coordinate is 25 centimeters, since y is changing, we know that when it says 25, it means that's the freeze moment, right? Since y is changing, we're going to say our freeze moment is when y equals 25.
Is this the y equals root x?
Y equals root x, yeah. Okay. And then we're going to find dy dt. Okay. So we find the equation of how they're related, which it actually gave us. Y and x are both changing. So how are they related? Well, they are related by that y equals the square root of x. So then we take the derivative to find the rates of change. So this is dy dt equals 1/2 x to the negative 1/2 dx dt. Okay. Then we're just gonna solve. We're just gonna put in everything we know and get out what we need. Get out what we are looking for. So we're looking for dy dt. So we put in 1/2. And then do we know x right now? No, so we'll just leave that x to the negative 1/2. And then dx dt was 3. Okay, so we have that dy dt equals 3/2 x to the negative 1/2. So if we have any variables left over like this, we just have to go back to our freeze moment and figure out what is x at the freeze moment, okay? We know what y is at our freeze moment. We just don't know what x is. So if y is 25 at our freeze moment, what is x? It is 25 squared, yep. 625. So at our freeze moment, x is 625, so we can come down here and change out x for 625.
Brian, can you go back?
Yeah.
I'm confused on what.
Okay, so I found my derivative. Did you get to here okay? Okay, so I got my derivative, and then I plug in my freeze moment to figure out what's going on at that exact instant, right? My freeze, it tells me when the y coordinate is 25. So I'm going to freeze it when y equals 25. So the freeze moment is y equals 25. So I plug in everything that I know at my freeze moment, but I don't know much, right? Yeah. I really only knew dx dt because it's constant, so that's 3. But I don't know x at the freeze moment just yet. So I have to go back to the freeze moment and say, okay, if I know that y was 25, can I figure out what x was at that moment? Just like those triangle problems. Like if I know what one of them is, can I find what the other one is?
Yeah, okay.
Yep, so I found out if y is 25 at the freeze moment, the x has to be 625. So then I come down here and I plug that back in here, and then I'm just going to rewrite this. This is 3 over 2 root 625. And the square root of 625 is 25. So that's what we just figured out, right? So this is 3 over 50. Is that what it's supposed to be?
Yeah.
Okay. Okay, we're going to do an AP problem now.